Okay, let's unpack this. Imagine a tool that doesn't just help you design buildings, but fundamentally transforms how you learn about them, how you visualize them, and even how you collaborate. We're talking about Autodesk Revit today.
Right. And what's fascinating here is how one piece of software um, really bridges the gap between academic theory and real-world industry practice.
Yeah.
It's empowering the next generation of architects and engineers. It really is.
Yeah, that bridge is so important. So for this deep dive, we've looked at, well, quite a few sources, and we're focusing specifically on Revit's powerful role for students and researchers in architecture and civil engineering, really tailoring this for you listening.
Exactly. Because Revit, at its core, it's a dynamic platform for BIM that's building information modeling, not just drawing.
Mm-hmm.
So our mission really is to explore its tangible applications, how it actually boosts learning and, cutting-edge research.
So what does this all mean for you, whether you're a student looking to build an impressive portfolio, or maybe you're a researcher pushing the boundaries of sustainable design? We're about to find out. Okay, so we've kind of set the stage. Revit is clearly more than just another piece of software. It's this comprehensive platform. For students, you mentioned it's about getting them ready for the industry. Let's dig into that a bit more. How exactly does it help them?
Well, first off, it gets them using industry tools right away. BIM workflows are pretty much standard now in architecture, engineering, construction firms. You have to know it. But it's more than just the process. It's the visualization. It's incredible. Students can build these information-rich digital models, not just pretty 3D pictures, but models with data,
Data, like what? Exactly.
like
Yeah.
analyzing energy performance, for example,
Yeah.
or clash detection, making sure a pipe doesn't run straight through a beam. Very practical stuff. They can even simulate the construction sequence virtually. These are skills top firms are absolutely looking for. Non-negotiable, really.
That's a massive advantage, isn't it? Giving them a head start on solving real problems before they even graduate. And what about teamwork? Because design is rarely a solo effort in the real world.
Exactly. That's a huge plus. Revit is built for collaboration. Think shared models, cloud integration. Multiple students can work on the same project, different aspects, simultaneously.
Live updates.
Yeah, seeing each other's changes in real time. It really mimics how professional teams operate.
Mm.
And that builds those crucial soft skills.
Yeah.
Communication, coordination. It all leads to a much stronger portfolio. Gives them a real edge for internships, for jobs.
Got it. So industry skills, visualization, collaboration, portfolio building, huge for students. But let's shift gears slightly. What about the researchers, those pushing the envelope? How does Revit elevate their work?
Okay. For researchers, Revit unlocks some really deep capabilities. We're talking advanced simulations, rigorous analysis. Think about analyzing exactly how heat flows through a specific wall assembly across an entire building in different seasons, or optimizing complex HVAC systems in something like a hospital, trying to really minimize energy use based on simulated airflow. That level of integrated analysis is powerful.
Wow, okay. So it's moving beyond just design into like predictive building science almost. How does it handle that complexity? Are there specific tools involved?
Yeah, a lot of it comes down to supporting truly data-driven design. Revit integrates really well with visual programming tools. Dynamo is a big one. Researchers can use it to script complex design explorations, maybe test thousands of variations for structural efficiency, something a human just couldn't do manually in that time.
Parametric design, right?
Exactly. Parametric design, you change one thing, and the whole model intelligently updates. Researchers can tweak a parameter, say window size or shading depth, and instantly see the impact on energy, on structure, on daylighting. It just accelerates discovery.
That idea of automating discovery is pretty compelling. And, sustainability is such a huge focus everywhere now. How does Revit play into that research?
Oh, it's critical there. Revit is fantastic for sustainability studies. You can do detailed environmental analysis, maybe for green building certifications like LED, calculate embodied carbon in materials,
Yeah.
design for specific climates. And what's really key is how it helps bridge different fields.
How so?
Well, because you have this single intelligent model, it brings together architecture, civil, mechanical, electrical engineering. Researchers from all these disciplines can collaborate on the same model, leading to much more holistic, integrated, and frankly, innovative solutions. It breaks down silos.
Right. So looking at the big picture, bringing Revit into universities, into research labs, it's clearly transformative. It's not just teaching software skills, it's equipping future professionals, future innovators, with the tools for, well, better precision, efficiency, and exploration. Hopefully this deep dive has given you a shortcut to understanding that impact.
And it really makes you think, doesn't it? It raises an important question for you listening. As technology like this keeps evolving, how might these tools not just support academia, but actually fundamentally reshape the entire landscape of how we teach and research design and engineering in the years ahead?
A powerful thought to end on. Thank you for joining us for this in-depth exploration.